Yeah, so Nebius, welcome round Div1 plus Div2. First problem, blame king. So let's see this T number of trace A and B. Position of the cell where king wants to reach, and currently kings is at 0, comma 0. You have to tell the minimum number of steps that king can reach at that place, right? Minimum number of seconds, yeah, minimum number of seconds, minimum number of steps because yeah, one step, 1 second. So let's see with an example. Okay, this is kind of a rules. I will explain through example. What are the rules? He can like rules are basic one. He can just move to, like yeah, four basic positions like up, down, left, right. But he cannot take uh he cannot do same operation twice, or like he cannot like say he wants up, he walks up. In the next second, he cannot walk up, and all other possible options are there. But yeah, no continuous, how to say this, man, no continuous, they would say this like uh he's not allowed to make the same move in the continuous second. Okay, now move forward. So minus 4 comma 1, so you are currently standing at this point, let's say 0 comma 0, and minus 4 would be on the left side, and 1 would be somewhat upper. So let's say this is minus 4 comma 1. How would he reach over there? There are multiple ways, right? The logic for this problem, like this is an observation based problem, that first reach to, like let's say first find what is the minimum, absolute minimum, like I did it like that way. So what is absolute minimum? Like minus 4 comma 1, absolute of these are 4 comma 1, and then the minimum of them is 1. So first reach 1 comma 1, that will take you 2 steps. Okay, so now from 0 comma 0, now you are standing at 1 comma 1, using 2 steps. Now you have to go 2 comma 2, then 3 comma 3, and then 4 comma 4. This is what you have to do, right? So now you reach up the 1 comma 1. Now one coordinate is same, like one any one of the coordinate will be same, will become same, right? This would create problem if this was minus 4 comma minus 1. Okay, then you say this is 4 comma 1, and then minimum is 1 comma 1, and then yeah, but you are thinking that in 2 steps you reach 1 comma 1, but actually you reach minus 1 comma minus 1. So again, two things are same. Now how many steps you need to reach from 1 to 4? Basically 1 to 4, the just a straight line distance, but the distance is 3, but you will need 5 steps. Why? Because you cannot take same step again, so you will do some random step, or I can say just wait. Okay, you do one step, then wait, then do one step, then wait, then do one step. So 3 plus 2, that's 5, right? So in this way we could have done this one. Are there any multiple ways, like uh yeah, the logic is that instead of waiting, it's better to move like in one direction, then different direction, one direction, different direction, until you reach the point from where you have to just walk in one direction, and the distance should be smallest like this. The other possible way would be, right, this is 0 comma 0, this is again 4 comma 1. You reached 4 comma 4, which is not suitable. Like yeah, maybe it is also suitable. You reach 4 comma 4, but that will take you 8 steps to reach there, then plus 3 steps to come back down over there. So that's not what we are doing, right? So we are taking, actually that's why we are taking absolute, right? Not yeah, this was observation, and we are taking absolute. Let's code it up. Yeah, the first question, observational based problem. C in A, B, and then you have what? Take minimum. Let's say I say key x is equal to minimum of absolute of A comma absolute of B. Right now you will need how many steps, and R is equal to 2 into x, right? 2 into x steps to reach minimum comma minimum, like this x comma x, whatever it is, and then how many steps you require for that. Again, I'm taking difference, d into d is equal to absolute of like just absolute of what? something like this, and r plus equal to 2 into d minus 1 you will do, and then you can return your r. See out your r. That's how I did a problem. 7, 7, 11, 9, 15, 7 and 8. Okay, the thing is, if d is something, if d is not 0, then only you'll do this. Otherwise, if d is 0, you will be just minusing 1. That's not what we want. 7, 8, 11, 9, 15. Let's sum this up. Let's move to b1. As you would see, this is green, means this is accepted. Now let's do b. B was a good problem, kind of. You have been given basically an array of size n. That's how the patients are coming at this point of time. Like, yeah, and then you have been given k, which means the time that, no, the doses of the vaccine present in one box, kind of thing. Yeah, vaccine comes in pack. Each pack consists of k doses, right? And then you have d, which is the amount of time up till which I think vaccine can be used. Then you have W. W is the amount of time that a person can wait up to. Cannot wait more than this time, right? So for law, we have to find out how many minimum number of vaccine packs required to for all the yeah, patients. Now what you could have done is binary search is also one of the thing, that total number of packs that you would require in worst case. Like in best case you would require one, but that's not possible. Like, let's just see how many people are there. Just there are 6 people, and each pack contains 3, so you will at least need 2, right? At least at max you can need 6 each for each person. Then you can try out a mid is equal to, let's say, 4, and then you can say whether 4 is possible or not. So when you try at 4, you'll say key, okay, first I'll start from this. I'll just keep on moving until the time difference between the two peoples are just are less than the amount of time that it can be just open up to. So that time is just 5 seconds. So 1 to 3 only satisfied. So one vaccine for this time. Then you have to open another vaccine at time t equal to 10 seconds. But that is not a very good option because people can wait also. So I'm not gonna open this vaccine at just 1 second. I'm gonna say I'm opening the vaccine at 3 seconds, so that 3 plus 5 8 I can reach max. Then I'm opening this vaccine at 13 second, 13, and then this yeah, I'm giving this person at 13 second, in this as 14 second, reading this in just 18 seconds. So 13, 5, 18. That's fine. Okay, that satisfies the thing. So that is one way how I did. I just did like I did not did binary search. I just did a normal iteration, and I'm opening every vaccine at a point. Hmm, I'm not trying out all the possibility to what is the minimum number of vaccine. I'm just finding out what is the minimum number of vaccine that you can. So if you have that number, then you can just check whether this number satisfies or not. That's also what you can do. So let's try binary search now. The main logic is to give each person as late as possible. So open at if first person comes up, like first person, obviously the person coming is ascending order. Person come up in t second. I'll open the vaccine at t plus w second. That is the thing, so that I can cover a maximum number of person with this vaccine, even if, like, yeah. But that's not possible in the second disk, right? Per second, 5 people came just in. So you just opened a vaccine. Let's say you say I'm gonna open it at, okay. If currently the waiting time is also 0, so you have to open at 3, and then give all this. You'll give all, and then vaccines are over. The people are still there, but vaccines are over. So you have to open up the another pack. That is also the thing. If the number of people you have just given the vaccine exceeds the amount of D, or not D, just K, then you open up the another vaccine, right? So now your the amount is like, yeah, you saying that I'm gonna give it this 3 plus 0. Okay, fine. Yeah, 4 cannot satisfy. Food. And now you are gonna say that for not for like I did like 4, but I equal to 0, not I equal to 0, L is equal to, let's say, what is the total number up there? Total number up there is, let's say, N. Okay. This is a minimum vaccine which I need, and R is equal to maximum vaccine is just N divided by 2, and then I say if it's good, like this number can. So we are passing it into a, so better to use a vector. Now how to check whether this point is good or not? If this point is good, I'll try L is equal to M, R is equal to M minus 1, and else I will try L is equal to M plus 1, and I also have a best equal to, I'm trying to minimize, right? So N, and best is equal to M. Best and L. Now let's make a good function. N is equal to v dot psi 0 to n I plus plus. Now you just need to check basically, or you could have used while. While, nah, this is also fine. If I is greater than basically, you should also pass the parameters like int k, what is w, what is d. That also plays a role. So I'll just say when I open the previous pack, right? And yeah, that's about it. If this person comes up and can take the previous pack, if a of I is greater than, not greater than, less than equal to previous pack plus how much time does it remain? It remains to, I think, w time person can wait, d time that pack can remain, right? If that's greater than less than equal to this, and I would say like okay, also the current number of present in the, yeah, that current is just minus one present, right? And then I would say that c minus minus current minus minus, if c is equal to 0, p is again equal to minus 1, like previous vaccine cannot be useful. In this case previous vaccine can be useful, and you can just say if p is not equal to minus 1 and right, previous vaccine can be useful, then check if previous vaccine plus d is greater than equal to ai can discover up c minus minus c equal to 0, this else part, like now you need to open a vaccine because either previous vaccine does not exist or this person cannot take that previous vaccine. So I'll say c is equal to k minus 1. Okay, one vaccine I'm using on this person, and I'm saying that previous of is equal to this plus w, that person can wait up to this time. I'm gonna open up that time, and yeah, that's about it. Like you just need to return how many vaccines that you used. Again, I don't know the sense of the bind search because I'm doing what I did in just normal thing. This will give me exact how many vaccine that I required for this array. But yeah, that is about it. R is less than equal to M, something like that. I know it would work. I do bits. 90 minutes for two question. AI was not declared. As a KNMD. 24 23 23231 y4 man in this. all threes and 1 4. So error size p minus 1 c minus 1 r equal to 0 0 to n f p is not equal to minus 1, and this is so first it equal to r equal to 1 and then c equal to k minus 1, which means how many vaccines do you have? K is just k was just 4 in this case, right? I guess you'll say 4 minus 1, only 3 vaccine left, and then I opened vaccine at 3 seconds. Okay, now that's fine. Then this reason c minus minus, only 2 left now. I think equal to we have to do. Hmm. So again, this is fine, and if I submit it, it should be fine. I don't know, but the thing is, we can do this without binary search, like just exact the same thing. Because if you're checking whether this is valid or not, I'm not checking whether that is valid or not. I'm just checking. Yeah, that's the thing. I'm finding optimal answer, and then I'm checking whether my optimal answer is lesser than or equal to this or not. How to check whether it's this thing is valid or not? Like I have number 3. So up till that range, I can take. Still not getting because that was my previous idea. So now what I'm just gonna say is that instead of this, instead of this, and we already know, yeah, everything we know. Like P, this, I just need to figure out this, and then this, and then this, and this. Just see out your R. Be accepted, but what's point of doing that? I don't know. Like maybe because binary search people are applying in different way. Like the way is that when you can check whether this is valid or not. But my way of checking whether this is valid or not, I'm finding optimal answer and then checking that whether it's greater than or equal to optimal answer or not. Because anything lesser than optimal answer won't work. So R is my optimal answer, and then I just returned it like this. What is the issue in this? C in C R equal to 0, 0 to n. Okay. Minus 1 is equal to k minus 1. Okay, let's check what is the difference between this and what I submitted. Okay, so basically you are decrementing your CR, right, which is your current number, whatever your C is. So you should check that whether C is there or not, right? Because there can be cases when C becomes equal to 0. 2, 3, 1. Also, your C should be 0 initially because current number is 0 initially. So minus 1 and then that. I think like yeah, the bigger thing was this only. And let's try to submit that first. Like C is minus 1 because C initially 1 minus 1 doesn't make any difference. But the thing is that while you're decrementing C, that C should be greater than equal to 0, right? Greater than 0. Like if C is already 0 and like over here, P is something but C is 0, you cannot do anything because you're doing K minus 1. It could have been possible that like K was just 1 and C became 0. P is still something. P is still something. This is also fine, but C is 0. C minus minus, and yeah, that for that C should be greater than equal to 0. So that's about it. Now let's do the C and D in the next one. Okay, bye.